much for coming. This is pretty much the first event of the year for the Harvard Science of Psychedelics Club. I'm Andrés, and I'm one of the founders of the group.
I'm Ken Shinazuka.
We're both undergrads, and we try to hold lots of events focused on psychedelics, consciousness, not just in research, but also related to meditation, and we do a storytelling session in October. We're going to have Michael Collins come in October also. There is a graduate student group too, so if you're interested and you're a grad student, let us know. There's an email list for that as well that we can get you on. And if you feel like you're not fully in connection with our communication channels, email, Facebook, also let us know and we'll get you on to that as well. Cool, so I guess a little bit of background too. Kenneth and I were both working with Qualia Research Institute this past summer.
Yeah. So Qualia is a research nonprofit dedicated to finding the science of consciousness. Andrés, who's going to be giving the talk today, is the director of research at Qualia Research Institute, which is also based out currently in the Bay Area. QRI happens to all be here in Boston as well. So we've got Mike Johnson, the CEO, and Romeo Stevens, the director of operations, right? And also Quentin Ferris, who's another member of the QRI team. And we'll also probably be hanging out afterwards, so if you have any questions for Andrés or the other members of QRI, they're more than happy to talk to you.
Cool. And without further ado, let's give it up for Andrés.
All right. Hi, everyone. Thank you for coming. Maybe feel free to not participate, but just really curious, kind of like a show of hands, maybe like roughly how many of you have ever tried any kind of psychedelic? Okay, yeah, it sounds like maybe like 90%. How about like a vaporized DMT? Okay, good. That's probably like 20%, 25%. That's awesome. So kind of like this talk is going to be about the hyperbolic geometry, DMT experiences. This is the original article, was published in 2016, and we've been kind of like iterating a lot over it. Yeah, I think like this is the first time I'm giving this talk. As far as I know, nobody has seen it. I haven't seen it. Yeah, so I'll get started. So, a thermoscope. So it used to be believed that there were a whole lot of different types of temperatures. Kind of, they used to call them, I think, like damp cold and dank cold and like crisp heat and like searing heat and like humid heat. And in the 16th century, like people were really skeptical. How can you possibly measure some collapsal of these like weird temperatures into just one number with like a device like that? There was tremendous amount of skepticism about thermometers when they first arose. And it took a while actually for them to be good in the sense of being like calibrated properly. Apparently, people used to think that all caves had the same temperatures. They would calibrate thermometers in caves, and like they wouldn't match up, and would use that as evidence that temperature is not a real thing. It's not so kind of like with that in mind, is it possible to have a thermometer for how high on DMT someone is? What the valence of their experience is. Valence is basically how good or bad an experience feels like. The information content of their experience. So what I wanted to think about these as I continue in the presentation. Like, is there maybe a way in which how high on DMT you are is actually an objective feature of the world, and it not collapses perhaps into like, well, I don't know, maybe there's kind of like a turned on, turned off version or something. But maybe like temperature, there's like a sense in which you can quantify how heated up you are by a psychedelic. So how do you take something qualitative, something like the DMT experience, and turn it into math, potentially a few set of values? So I'm going to give you an analogy. So the analogy is like this. Imagine you're a botanist. You just like started. You're an undergraduate. And people in your field are really proud about how they know everything there is to know about leaves and plants. And they've basically cataloged the entire space. And there are like some reports somewhere, like some dubious reports that there's like other types of leaves out there. There's like other types of plants that are not in the textbooks. but somehow the textbooks are missing some really key component. And you go and you study more. You kind of like realize, like, hey, like they're talking about like venation patterns, margins, shapes, arrangements. And yeah, all of these extremely detailed vocabulary to talk about, something that is ultimately fairly qualitative, which is the shape of leaves. So, in a sense, you have the right to be extremely skeptical that there's like a completely new category of leaves out there that you have never seen before. So you just dismiss it. But then maybe a friend of yours, a very close friend of yours, says, hey, like we went on a trip on a boat. We arrived on an island that probably has different evolutionary selection pressures, and we saw things that are not in your book. Okay, it being like very close friend of yours, he says, okay, I'll take the plunge, I'll take the trip and see what happens. And the first time you set foot out of the boat, you see this, and you're shocked because you've never seen anything like this. I mean, this is not exactly a leaf, is it? In what sense is this a leaf? I mean, it's like really weird. It's like this very long, prolongated leaf with a lot of curls and stuff. And okay, after the shock wears off a little bit, you walk a little bit further and you see all of these other things. It's like, okay, that can't possibly be a plant. It's like, where is that in my chart? But anyway, you become convinced that, yeah, there are other types of leaves, and you go back. But you maybe don't necessarily have perfect visual memory. You don't necessarily have the best ability to kind of describe what you saw. So you go back to the community of botanists and you say, no, like actually I did see something different. It's not in your tables. And their response is, you're tripping, man. Indeed. But I'm not the only one. So you take, for example, a mathematician to the island. And then the mathematician comes back and says, yeah, what happened is those plants are hyperbolic. And that's what makes them different. Now, you may be skeptical, it's like, hyperbolic, what do I mean? Well, again, I'm not the only one. Type in Google Images, hyperbolic leaf, and you'll get these results. So in what sense is kale a hyperbolic plant? So what I just mentioned is actually kind of an introduction both to psychedelic epistemology and also to hyperbolic geometry, as we'll see in a moment. So yeah, this person will now be able to say, I was sleeping, now I'm awake to the curvature of leaves. There's this entirely new dimension I wasn't taking into account. And as long as you just, have all your diagrams in a flat textbook, you don't try to represent curvature, there's a very important feature of the world you may be missing. So, okay, introducing hyperbolic geometry. How many of you are familiar with hyperbolic geometry or acquainted with? Okay, so it's this very, very cool thing because in a sense, surfaces have a curvature. And kind of like very, very broadly, like a sphere has a positive curvature, a flat surface has a zero curvature, and then hyperbolic space has negative curvature. And you can kind of see like some of the pictures above. All of those are spherical geometry. It has to do with basically how many angles can you stitch together at a corner. So if you stitch together 5 equilateral triangles, you will get this icosahedra, this thing that kind of has a nice closure. If you stitch together 6 triangles, then you'll get this thing that repeats endlessly in a plane. And if you stitch together 7 triangles at a corner, and you actually try to do it, you'll see like, well, it kind of like works at first, but then it gets kind of messy. It kind of like gets really wrinkly, and you need to kind of like if you flatten it in some place, kind of like the wrinkleness goes elsewhere. It's very difficult to manage those things. But broadly speaking, like you do have this general pattern of kind of like how many angles you can fit on a corner. So the example of, for example, the top right hyperbolic circle there, there's like squares and pentagons, right? Like 3 squares at a corner and 1 pentagon, which is really not possible in a flat surface. It's kind of weird. You have kind of this square lattice with a few pentagons infiltrated, and somehow you still manage to work with it. You also have kind of like right below, you have 5 triangles and 1 square. That also adds more than 360 degrees, so that doesn't seem really possible. The last square, the last circle, which is unfortunately cut out due to the projector, but you can see there's blue squares, yellow octagons, and then there's this red thing that you count like 1, 2, 3, 4, 5, 6, 7. It seems like it never ends. It's like this infinitogon or something. And how can you possibly fit that into a plane? We will actually come back to that shape. That shape is actually important for understanding DMT experiences. But yeah, the takeaway is kind of too many triangles. If you have too many triangles and a small space to fit them in, at some point you will kind of like be forced to stitch more than 6 of them in a corner, and you'll start to get like this wrinkled hyperbolic surface. There's also this kind of equivalent aspect that's called kind of the hyperbolic symmetry, as opposed to the Euclidean symmetry. So it's a very well-known fact in math that there's only 17 possible ways of tessellating a 2-dimensional Euclidean space. Those are the shapes in the left. They're called the 17 wallpaper symmetry groups. And basically they're made of like symmetry elements. So for example, you can use like mirrors, you can use rotational symmetry, you can use glide, which is combining mirror and translation. And there's only so many ways you can combine those and actually cover the space properly. In hyperbolic geometry, there's an infinite number of ways of doing it. So you can stitch together 17 triangles at a corner and just make that a symmetry. You can put, I don't know, like 100 different mirrors intersecting at a point and then making a symmetry out of that. You're very unconstrained on hyperbolic symmetry. But in Euclidean symmetry, you're very constrained. You only have 17. And it's mathematically proven that there's just no other way of doing it. There's also kind of like this sense in which these different symmetries have like a different level of what you might call kind of like detail or information. At the very top, top left, you have kind of like, it's just based very simple translation. Whereas as you go down, it gets, 6 rotational symmetry combined with a 3 rotational, 2 rotational, it just gets more things crammed in. It's kind of like more information in some sense. And if you're talking about like information in hyperbolic symmetries, you can just cram in as much as you want. You can put like mirrors and rotations and glides in all sorts of ways and still make it fit somehow. And kind of like another important metaphor here is this sense of kind of like the branching factor of different spaces. So if you're in Euclidean space and you kind of like draw a circle and you calculate the area as a function of the radius of the circle, you will see that it grows quadratically, right? It's like pi times r squared, like it grows as a function of the square of the radius. If you do the same in a hyperbolic surface, you will get something that is exponential. It's not exponential at the very beginning, but it very quickly, basically asymptotically, becomes an exponential curve. So in hyperbolic space, you can fit a lot of things in a relatively small circle, a circle with a relatively small radius. And that turns out to be really important as well for explaining DMT, as you will see. But the important thing of this slide is kind of this concept of the branching factor. That in a sense, if you're in a hyperbolic space and you start kind of like walking randomly, it's very unlikely that you will get back to the same place. Because basically every time you take a step, the number of ways in which you can get further away just continues to grow as opposed to the number of ways in which you can actually get back. As opposed to, if you actually live in a single line, then, it's kind of like a toss. If you could be going further or closer. In hyperbolic space, if you get lost, the good heuristic is like stay where you are. Don't try to find your friends. Just stay there. And yeah, the branching factor, so a lot of binary tree, for example, it's very difficult to represent a binary tree with just a lot of levels in Euclidean space. But in hyperbolic space, it's very easy. You can just basically add it and it becomes kind of the skeleton of the space. And again, it's the kind of this concept of like each step you take, it multiplies the number of possible branches you can take further. And coming back to the leaf metaphor, something really cool is that you can tell the geometry of a leaf by the venation pattern. I don't know if that's how you pronounce that word. Venation pattern. Well, the patterns to the left are all Euclidean. I mean, you kind of need, when you don't have like perfectly regular shapes, you need to do some trickery to kind of get the average of the angles, but you can still calculate like basically what is the curvature implied by a particular pattern of veins. And if you see a pattern of veins in a plant that looks like just 7 triangles at each corner, then you know that plant is hyperbolic. And that kind of shows up in kale as well. Right? So to the left is kind of a kale that is more in the Euclidean side of the kale space. And to the right you have kind of the hyperbolic kale, which the image doesn't show, but like at the edges is like very wrinkly. It gets wrinkled because there's not enough like Euclidean surface to be able to accommodate it, so it has to kind of like bend to be able to exist. And the veins there will look much more like these 7 triangles at a corner than in the right, and also the branching factor. Like you can think of it as in the left, kind of the branching stopped. In the right, the branching continued, and so it's creating these wrinkles. And yeah, you can kind of describe, in a sense, different kales by just talking about their venation pattern, their branching factor, their curvature, and all of those are different ways of getting at the same thing, which is how hyperbolic they are. So with kind of that as a background, let's kind of like now delve into DMT phenomenology. So in the original article, I kind of like created this ontology of 6 levels of DMT experiences. There's probably more, about 8, but I'm adding 2 of them are kind of like subtypes of those 6, and I'll walk you through them. So DMT levels. So they are 6. They are threshold, chrysanthemum, magic eye, waiting room, breakthrough, and amnesia. And again, like a lot of people would be very skeptical. It's like, is there any, like rational taxonomy for different levels of DMT experiences? But if you're a consciousness realist, if you actually think that there's math underlying this particular state of consciousness in which you are, then yeah, there's going to be some mathematical feature that determine how high you are. And there's like a sense in which that can be made very objective. So this is kind of the overall trajectory, very big picture. We'll come back to this picture a number of times. But suffice to say, kind of the curve is representing the level of highness as a function of the minute in which you are after inhaling, let's say 3 tokes. I mean, this is kind of like aiming for the 30 milligram range, which is kind of where you actually get breakthrough type experiences. And let's talk first about threshold. So this is kind of like between 1 and 4 milligrams. At this dose level, DMT does look and feel quite a bit like other psychedelics. So if you've only taken very small dose of DMT, you may think like, oh, it's just like mushrooms. And there's a sense in which, yeah, I mean, like colors get intensified. A very, very common description I found in the people I've interviewed is it seems like there's kind of an intermediate medium between you and the things around you, and that disappears. It's kind of like the air got sucked out of the room. You see things very, very crisply. The other thing that people mention is it feels like you turned on an HD TV feature for your vision and your sensations. Everything becomes very crisp. There might be even a sense in which low doses of DMT may be objectively improving your ability of visual discernment. It's just that maybe they're like very calorically expensive. That's a possibility. People tend to be pretty convinced that their threshold DMT experiences were like, no, I actually was perceiving the world in a more accurate way, in a sense. Although that starts to not quite work if you kind of like go towards like the upper ranges of the threshold. And that's where like the other kind of like more classic psychedelic effects appear, where you see every surface starts to be tessellated with particular symmetrical groups. And there's this thing that happens. Basically, the information copying threshold becomes lower, meaning that if you see a triangle somewhere in your visual field, it's very likely that will entrain another triangle in the same position and in the same shape, just displaced or potentially protected in some way. So every tessellation tends to happen kind of like with a nucleating factor. There's like a piece of the visual field that has like like the 632 symmetry, one of those I was showing, and that kind of like starts to grow and eventually covers an entire plane. On kind of the upper ranges of threshold, that just happens everywhere. So that's kind of like the level. I then found out it's like a pretty solid, qualitatively different level called the Symmetry Hotel. So that's kind of roughly 4 or 5 milligrams of DMT. And the properties of that one is that every surface is covered with wallpaper Euclidean symmetry groups. So like people describe it as like just going to the absolutely most luxurious possible, hotel, futuristic hotel you could possibly be in. Every surface has these like holographic wallpaper symmetry groups covering it. However, you're still seeing the objects that are around you. Like, it's kind of like another description people have used is, your picture of the world is overlaid with another copy of itself. And kind of like there's this thing called the moire patterns, when you have like a grid and you superimpose another grid on top of it, you get these nice repeating patterns. So like that is happening, but in every surface of your experience. Textures like this, you can represent kind of the x-axis as kind of time. So a given surface is not only tessellated, it's also evolving. But the thing I want to point out is that even though this evolution of patterns, it's very diverse in some sense, it's still all Euclidean. All of this is the star 632 symmetry. It's just a Euclidean symmetry. It's just, encompassing the entirety of your experience. And you get things like, let's see if I can play this. All right, I'll show it to anybody afterwards. But yeah, those basically rotate. It just like shows that the symmetries are not just like static. It's not just that you get these beautiful Euclidean symmetries. They're also rotating and transforming along their symmetry elements. So if you see like a 6 rotational symmetry, typically there's also going to be a vortex on that symmetry, and there's like everywhere is like that. Everything is constantly moving, but in this very orderly mathematical way that can be described with Euclidean geometry. And that's kind of the upper range threshold. So what happens when you get to Chrysanthemum? So that's the first intimation of hyperbolic geometry on DMT. So the Chrysanthemum, anywhere between 4-8 milligrams. So remember the thing I said about like how the triangle kind of like starts to make copies of itself and it covers the space? Well, if the copying threshold for your experience becomes sufficiently low, you will have more triangles than you know what to do with in a given surface. So basically that makes it your surfaces start to become like kale. And you get kind of this unfolding. People describe it as like unwrapping a present, for example, or the blossoming of a flower. Those are like very common metaphors for the chrysanthemum. And it's basically kind of like this start out as a Euclidean symmetry group, and it quickly evolves into a hyperbolic symmetry group, and it acquires some type of texture. And if you take just that amount, that's going to be the peak of your experience, and it's going to be more intense, typically, than even a high-dose mushroom experience. But it's just going to be very brief. Now, if you take a little bit more, then you get to this thing called the magic eye level. So the chrysanthemum, again, is like slightly textured. But now there's so many triangles and so many shapes that it's not just enough for the texture to be, have like a little bit of a texture. You actually need the curvature, and the curvature actually needs to be accommodated into a depth map in order to be able to deal with all of that excess figure, all of that excess energy. You probably can see there, and you're free to come after I finish, but basically there is a lobster there, and the phenomenology that people describe as the magic eye level is very, very similar to actual magic eye, or they also call it autostereograms, where you have this texture that it seems like it's very repeating, it seems like it doesn't have much information, but actually it's encoding a depth map. And that depth map contains the semantic content of the experience. So you can really kind of factorize experience into, well, you have the semantic content, depth map, and then the texture, which may contain more of the emotional quality of the experience. So to illustrate it, you kind of get this. This is the depth map that you get out of the magic eye. So here I'm not representing the texture, I'm just representing the semantic content. So the thing to note as well is that sure, you have that depth map, but it's all represented with the same texture. And that's something that people describe like a lot after like DMT. If they hit kind of the magic eye level, they will say like, oh, I went to this crazy ice cream shop, and then like a cathedral, and then like I went into caves and whatnot. But everything was made of the same thing. Like it was a world where like everything just had the same texture. It was, and and I think the left representation there is kind of a good representation of that, where you have like this underlying texture, but then like there's information encoded in the depth map of that texture as well. I can tell some people are relating to this potentially. And yeah, the other ones too. I mean, like there's people also talk a lot about like kind of like the duck rabbit illusion, in the sense of like, yeah, there's a depth map, but then it's kind of an unstable depth map, and then it collapses back into the chrysanthemum, and then it reorganizes itself into a different depth map. So it's not like in the higher levels, as you will see, that things actually feel solid. Here they still kind of feel somewhat ethereal, and they're like very malleable. Okay, so what happens if you take a little bit more? Crystal worlds. So in the same way as threshold, if you took enough, you know, it saturates the two-dimensional space with Euclidean 2D symmetries. If you get to the magic eye level and you kind of take a little bit more than that, then it's going to saturate 3D space with 3D symmetries. And just as there are like a finite number of possible symmetries in 2D, 17 wallpaper symmetry groups, in 3D there's also a finite number. They're called space groups, and there's 230 of them. So there's also a limited way in which this can happen. But people describe, you know, I went to a crystal world that, you know, had like the same shape repeated all over, and I was that shape, and I was resonating with that shape, and it just lasted forever. Like, there's this sense in which that just doesn't change. It's just kind of like a fixed attractor in consciousness. Also, people describe it as being extremely blissful, and we will come back to that. Why would this be a blissful state of consciousness? But the same happens, again, with the Symmetry Hotel. At some point, if you add more energy to something that is already saturated in the Euclidean curvature, you kind of run out of space to put the extra energy in, and you are forced to actually turn the space into a hyperbolic space in order to accommodate all of that. And that's what happens at the threshold between the crystal world and the waiting room. So the waiting room, 12 to 25 milligrams. Oh, maybe, huh. Okay, all right. So yeah, 12 to 25 milligrams. Basically, this is where space itself actually becomes hyperbolic. And a lot of things start to happen that are impossible in normal everyday life. So one of the examples is kind of in the lower left. You have what's called a hyperbolic honeycomb. So there's like a way of tessellating space with a hyperbolic repeating pattern. It's a hyperbolic tessellation. The one on top of that is a hyperbolically curved surface, but it's also morphing from the point of view of its embedding, basically where it is in 3D space. So now imagine that, but happening to a 3D space. So the 3D space may locally have the same curvature, but then the whole thing is morphing. So people talk about like space distortions, space-time distortions, things that again sound like the guy going to the island and saying, I saw a different kind of leaf. It's impossible to represent. It's like, no, it's totally real. It's a totally real thing. It totally happens. It's just getting the dose right. And then, yeah, the other thing is just like every surface, I mean, just as like in the chrysanthemum, it's just like covered with symmetry groups going through their own symmetry elements. And any kind of symmetry breaking, as in the bottom right, basically propagates very quickly and spreads throughout the entire experience. There's also, at this point, DMT entities. So DMT entities are very interesting, and part of it is that they are completely different depending on the level in which you are. So on the magic eye level, people describe them as being very impersonal. So basically, it's kind of like looking at a TV, and there's like interesting things going on in that TV, but it's just a TV. It's some kind of transmission. It feels like you're not actively kind of interacting with them on a person-to-person basis. But if you get to the waiting room level, people describe it as there's a kind of higher form of intelligence, and you telepathically communicate with it. Now, I've gotten these reports from people, you know, who have like a PhD in math, from a top university. It's not just crazy people saying this. Now, my interpretation of that is not that you actually interact with a higher intelligence. It's more that your state of consciousness is such that I have this new tool, this new curved space. I can represent and understand things that I couldn't possibly have understood before. And in that sense, you're getting acquainted with a higher intelligence. It's just a baby higher intelligence of your own making. And yeah, I mean, this level tends to be extremely confusing for people, partly because they don't know what to do about the entities. And then there's breakthrough. If you increase the dose a little bit. Low breakthrough, basically the entire space just becomes a hyperbolic honeycomb. You also start to see this thing that's called basically inversions and projective inversions, where the entirety of the space seems to be collapsed and flipped over into a finite space. Really weird, but apparently happens. And high breakthrough, the hyperbolic honeycombs actually become so, like the curvature is so high that you can actually see things such as like hexagonal lattice being just one side of one of the cells in that space, which is something that is not actually possible in Euclidean space. It's definitely not possible in lower curvature hyperbolic spaces. It's really weird that this lattice that goes on infinitely is just like the side of a particular cell in that hyperbolic space. And then there's entities, which I tricked you here. They don't look a lot like that. Actually, that picture, you may be able to see something like that on the magic eye level. But on the breakthrough, you don't see that. On breakthrough, you just see more of this stuff. There might be a sense of higher intelligence, but no, any kind of like organize the shapes into anything recognizable, like no, that's completely out the window. That doesn't exist in that space. Now, I do believe some people actually project and believe that, in a sense, like they kind of like reinterpret a little bit the high breakthrough with what happened afterwards, kind of like to give it meaning. But I think of it as just like such an extraordinarily highly energized state of consciousness. Like, yeah, it cannot actually sustain anything like a table or something like that. So, you remember the infinitogon I was talking about? So this is kind of like an indicator of kind of the overall curvature of the space. So to the left, low breakthrough spaces. You have 4 pentagons at a given corner. Then you increase the curvature, and then you get ideal vertices. You get basically polygons that meet at infinity, which in a sense also means they quite never meet, right? Like it's sort of like somebody saying like, oh, if you have a line, you can think of the line as the perimeter of a circle with the central point at infinity, right? Okay, sure, like you can think of it mathematically, but in practice, you will actually never meet. But then you can actually have like even higher curvature, and then you get these things that are called hyper-ideal points of infinity. They don't even meet at infinity. And based on phenomenological observations, that might be partly what accounts for the amnesia level. Basically, things that are impossible to remember. The curvature is so high you can't even actually form thought forms that you can bring back afterwards. So yeah, amnesia level, not usually caused by ego death as opposed to other psychedelics. Most people even report on breakthrough levels their sense of self is not that it's intact, but they still have a very clear narrative of like what is following what. Time distortions are not so extreme as in other psychedelics. So ego death is not really the cause of amnesia. The state is so energized that it becomes memoryless. You can think of kind of a boiling rocks to such a high temperature that all of the crystals melt. And just like no matter what happens in it, you won't be able to bring like a particular snapshot of that state. Basically, there's just like no residue of whatever happened. And phenomenal time looping is so intense that it prevents counting. So you may enter into like these loops and you just have no way of knowing how many loops have you experienced. So yeah, amnesia level, probably not very useful. There's definitely not much you can actually say about it, although maybe there might be ways of making use of it in the future, and I might describe how towards the end of the talk. So, okay, so that was levels. There's also complexity, and kind of the metaphor here might be, how, to some extent, coming back to the thermometer, pressure was a big component of like why thermometers were unreliable. You had temperature, sure, like temperature would make changes, but also pressure would make changes. So like the two kind of like get confounded. And I would say it's the same when it comes to hyperbolic geometry in DMT. You have levels, and then you have also the complexity of the state. And you can kind of like cleanly distinguish them. So this is where I kind of like make this chart. Basically the energy/information content landscape. So on any given moment of a DMT experience, you're somewhere on that chart. So kind of like on the lower levels of energy, I mean, you recognize these, right? Like threshold, chrysanthemum, magic eye. The thing that is different is that I also added kind of this axis of information about to the complete left, when you have like close to no information, that's just a perfectly repeating pattern. That's as low information as you can possibly get. Then a little bit more information, you have twists, you have loops, you have basically the perfect pattern, but with a little broken feature. That's kind of like when you start introducing a little bit of information. You go even further on the information direction, you get to chaos, then you get to chaos plus noise, then dense noise, and then at the kind of extreme, you have just pure noise. And maybe kind of like a metaphor here is, for example, the experience of listening to a guitar as opposed to the experience of listening to white noise. Like you can listen to both maybe to the same volume. One of them, in a sense, contains a lot of information. Like the noise, in a sense, contains like maximum amount of information. It's just like there's nothing you can do with that information. And if you listen to, for example, a pure tone, it has very, very little information. There's also not much you can do. If you want to, for example, maximize computational power, probably somewhere in the middle, when you have kind of like a chaotic state or a partially chaotic state that kind of maximizes useful information. And I'll come back to that as well. In the upper ranges as well, DMT, what is it? DMT elves and the objects that they create with sound and all of that we kind of hear. That's not like complete chaos. It's also not complete order. It's kind of like a good balance in between, where you actually have these irreducibly complex objects. You know, these weird things that, for example, you have like gear mechanisms that have a prime number of teeth in all of them, and the whole pattern doesn't repeat until there's like the minimum common multiple of all of those gear mechanisms. So all of that would be, you know, kind of like right there in the middle, where it's like maximum useful information, not so much information that is just pure noise, not so little that is just a perfectly repeating lattice. Now, how do we actually come up with a kind of like ontology for the information axis? So the ontology for the level axis, as we talked, you can think about it in terms of curvature, dimensionality. You know, I explained how 2 dimensions pop into 3, and then like 3 dimensions force into higher 3-dimensional hyperbolic space. What about like the ontology of information? How can we, you know, generate categories for that? Are there like natural attractors there? And I would say yes, and actually we can use complex systems for that. So there's this really cool video from 1984 about video feedback. Video feedback is pretty cool. You point your camera towards the screen, and it generates these, you know, complex, interesting patterns. A lot of people kind of like spend maybe a couple minutes there and says like, oh, this is really cool. But what these people did was they spent months on it and just like tweaking the parameters of the angle and the zoom and the noise, and then figure out an ontology, or what are like all of the things that can possibly happen in a feedback system. And the ontology is roughly this. I mean, it's kind of these very big 4 categories. You have fixed point or equilibrium. You also have limit cycles, chaotic attractors, and noise-driven spatial structures. So here are some examples. This is a fixed point. You can even guess actually what the camera is doing there. The camera is presumably rotated 90 degrees. So that basically the horizontal line gets fed then as a vertical line, which gets translated into horizontal line, and the whole display is like stable upon the feedback transformation. And what this GIF also illustrates is that it could be fairly stable, it could be fairly robust, but if you disturb it enough, you may be able to knock it out of its attractor basin, and make it go into another fixed point. So in the case of DMT or high-dose psychedelics, perhaps fixed points would be kind of these like moments of eternity, perfectly repeating hyperbolic honeycombs type experiences. And a little bit more information, then you have these limit cycles. This is a very simple limit cycle. This is kind of on the side of a pattern that repeats, but it repeats very quickly, and all of the stages in the process of repetition are very similar. But then you can go to kind of like more interesting limit cycles. This is a pretty weird limit cycle. It's almost kind of hard to believe that the whole thing repeats. I mean, it does have kind of like the grounding point of a very simple state, but all sorts of complex, weird things happen, and this would be kind of like more off to the right, a little bit more information, but it still has like an overarching pattern. So it's not noise, it's not chaos. Then you have noise-driven spatial structures. Let's see. Yeah, I mean, this is really chaotic. Tiny amounts of noise basically massively get amplified into this feedback system, and you get this very, very chaotic state. So that might be kind of like further to the right as well. Then you have things that are like almost pure noise. Basically, any amount of noise just gets massively amplified, and you get this basically curtain of noise. And then you have like interesting states where basically it starts out very simple, and then it converges on turbulence, and then it becomes just a incredible amount of noise. The thing I really like about this GIF is that you can actually point to it and say exactly when things get turbulent. So it's kind of like, okay, it's pretty simple, and around here it gets turbulent. And yeah, I mean, you can think of kind of like these phase transitions into much more chaotic states as transitions into turbulence. And to a large extent, that also may account for a lot of the phenomenology. Okay, so you have kind of this axis, simple fixed point, complex fixed point, simple limit cycle, complex limit cycle, simple chaotic attractor, and complex chaotic attractor. Even these ones, right, you can kind of like now take them and describe them as a trajectory in the complexity energy space. In a sense, the first one, the limit cycle, actually starts out like very much to the left, and then it does kind of like a loop and gets back to the left. And the right one just kind of like pushes towards the bottom right, just pushes towards like the noise attractor. So the thing I want you to think about is basically trajectories. So a DMT trip is not only about how high you got, it's also about what trajectory you took in the energy complexity landscape. And that may actually matter a lot when it comes to what you bring back and what you're able to remember and what did you get out of the experience. I mean, a metaphor here is like how different ice crystals form. It's kind of specific conditions of temperature and pressure. And for you to get the exact shape, you need to actually, get the same conditions right. And when some people say like, oh, I had an ecstatic DMT experience, you've got to kind of like dig deeper to actually know what the trajectory was. But I do think like the trajectory really encapsulates a lot of the information about what a particular experience was. And you can even kind of think of this as a kind of engineering aspect. It has an engineering aspect to it, which is like, what do you want to get out of the experience might inform what trajectory you take. So here are just like 3 examples. If you want, for example, just to feel better than well, in the sense of like entrain some very high-grade meditation patterns, maybe you want to start in the symmetry space and just go up. Just go up into hyperbolic honeycombs. Don't mess with chaos, don't mess with other weird things. Just create these like hyperbolic lattice, be there and then come back. And that might be maximizing bliss. It might be maximizing sense of well-being. It might be maximizing the ability for you to bring back a positive feeling. On the other hand, if you're a mathematician, you're trying to do a scientific breakthrough of some sort, and you want to explore 3D hyperbolic geometry, then maybe actually angling a little bit towards complexity might be a good idea, so that you actually get to the kind of the top there with the DMT devices that have a lot of irreducible complexity. Now, on the other hand, if you're like most people, you probably have traumas. You probably have like a lot of problems that this experience can probably help with. And if you want to actually, in a sense, like solve inner problems that you have, probably the best way would be to go kind of like angling towards noise first, and then come back through the order region. Oh yeah, and we have a hyperbolic honeycomb over there for you to pass around. Thank you. So yeah, and the frame here is the frame of annealing, right? So similar to a metal, it starts out like cold work, a lot of like imperfections. If you want to kind of like, in a sense, if you want to make it naturally self-organize into a smooth lattice, maybe what you want is to actually, heat it with a bunch of entropy, get it very disordered, and then let it cool very slowly. And the reports that people kind of come back and say like, oh, it helped me solve, an internal conflict that I had, or it made me solve a mathematical problem or something like that. The annealing frame is generally going to be much more fruitful, which is that usually you have a lot of constraints on how you're tackling a problem. By heating up and go towards higher energy and higher complexity, you're in a sense dissolving those constraints. Robin Carhart-Harris talks about it in the sense of entropic disintegration, like all the constraints are basically becoming more soft. That allows you to do what we call neural search, basically explore many possibilities very quickly, possibilities that you usually wouldn't be able to explore because you're too constrained. And then when you find something that is more kind of useful, then you slowly cool down so that you can actually anneal that pattern and kind of stabilize it and keep it with you. So like if you already found a solution, maybe taking more might not be good because you may also heat it up and destroy it. There's kind of like a whole craft of how do you anneal a good solution on psychedelic states. Again, not something that anybody knows very well how to do currently, but at least with this we have some kind of physical analogy framework to be able to kind of like angle in the direction of getting better results. Yeah, so we're approaching the end. Is possible to have a thermometer for how high on DMT someone is? Well, one heuristic is to aggregate the curvature, the brightness, the velocity, the loudness, and dimensionality of the experience. And that'll give you a really good proxy for basically how high a person is. What about valence? Well, the overall symmetry and consonance of the state. The symmetry breaking and dissonance might also be analogous to basically how distressing and unpleasant the experience is. This would be a whole other presentation, but you can Google quantifying bliss, and you will find basically a presentation I gave in a paper about how to do this and why we kind of like might expect that the hyperbolic honeycombs feel a lot better than the chaotic or the noise state. And finally, the information content of the experience. We can bring again the ontology of complex systems, and we have simple or complex fixed point, limit cycle, noise-driven chaos, etc. Basically, the ontology of things that can happen in a feedback system. You will encounter those, and they will encode different amounts of information. The kind of end game here is something we call the Super-Shulgin Academy. Who here knows about Sasha Shulgin? Okay, so about a third. So Sasha Shulgin is probably one of the most advanced psychonauts out there. He himself synthesized 200 different psychedelic substances and empathogens, and he would take them and have his friends take them and write reports about them. And he would figure out everything about like the toxicity of it, the different thresholds. He wasn't actually that interested in phenomenology. He considered himself more of a tool maker. He was just like, okay, like we discovered this is psychoactive, let's go on to the next substance, and next one, and the next one. You can kind of think of a Super-Shulgin Academy as kind of an integrated approach that brings neuroscientists, it brings phenomenologists, philosophers, people generally in very technical fields, very bright, and philosophers. And it does the following. It trains high-quality consciousness researchers and psychonauts. It investigates the computational trade-offs between different states of consciousness. That's kind of like what I was describing, how different trajectories have different advantages and disadvantages. It finds new socially useful applications for exotic states of consciousness. It's like, oh, we discovered this 5-MeO DMT mixture that is really good for trauma, and like then everybody uses it. Practices the art and craft of creating ultra blissful experiences, and develops and maintains a full stack memeplex. That is to say, kind of a big picture of what it all means, which we currently can't actually paint because we don't know what's out there. We don't know what is in the status of consciousness. We are still in the moment in time where we're kind of like in the old world. We have no idea that there's this entire continent's out there. We have some reports, but still no systematic map of it. And here, like a plug for something that a couple of people I know are actually doing. And you may be surprised that you can actually have a legal psilocybin experience right now. And you don't have to subscribe to any religious or therapeutic framework for these. So the Advent Retreat, basically safe, legal psilocybin experiences in Jamaica. It's open-ended framework. So basically they don't say, oh, this is for therapy, or this is because we believe in this spirituality and come and meet our, our set of gods or something like that. Literally in their website, they say, if you want to explore consciousness, if you're going to, investigate the nature of reality, that's what this is for. And I can vouch for the people who run it. Yeah, they're very ethical, and it's attracting a lot of smart people. So I'm kind of like angling it as a plug for potentially the seed of a future Super-Shulgin Academy. So definitely check it out. And we're very interested in people from STEM fields and philosophy to sign up to openly discuss their experiences and conduct controlled experiments. Again, stepping away from this paradigm where these substances are just given to the general population, and then you have the scientists kind of like their lab coats and pretension of objectivity, just kind of like, oh, I can explain it in terms of the EEG patterns. And moving into the paradigm where there's basically the scientists are also taking the substances, talking with each other and figuring out what's going on. And with that, I'll conclude. Yeah, thank you very much. Also, want to say thank you to Winslow, Jason, Christian for funding us, and Jacob for helping organizationally. And yeah, this is the Qualia Research Institute team. Thank you. Right. So I started Qualia Computing about 5 years ago, and I started getting emails from psychonauts, and at first they were pretty sketchy psychonauts, but honestly, after I wrote a particular piece called The Algorithmic Reduction of Psychedelic States, I started to get emails from really smart psychonauts. I mean, people who have PhDs from top universities in STEM fields, and who take a lot of DMT. And so I've had the opportunity to basically have kind of anonymous back and forth over the years. So you could kind of think of it as more kind of the N of these would be around like 10 or so people, and it would be me asking them questions, and then coming like a year back, they say like, oh yeah, I did try that, and like actually this is what I experienced. And for obvious reasons, I can't say who they are. I don't know who they are, most of them. Yeah, I mean, I am pretty confident on the hyperbolic geometry angle. There's other things I'm not super confident about, but the hyperbolic component has been verified by enough number of people. I'm pretty confident. And something with the Advent Retreat Super-Shulgin Academy, hopefully we will start to be able to have like an open discussion about this by people who've experienced it. Over there? No, okay. Over there?
So this whole talk had me thinking about the safety of work hypothesis, which is that your language informs your structure of thinking. And when I've talked to my friends and we all study AI, we talk about things in terms of agents and reinforcement learning. And this seems like a sort of different parameterization for the experience. So do you think there's some sort of like correctness to this interpretation, or is this just like a selection bias because you're a mathematician and your friend's a mathematician?
No, that's a great point. So the key thing to bring here is one way in which you can interpret actually what happens in the specific things that you see on a psychedelic as opposed to the things that you feel more broadly has to do with the fact that when you recognize something, that works as an energy sink. So it's kind of like you're exploring a lot of configurations. As soon as you find something that you've seen before, it's kind of like applying cold water and crystallizing it. So of course, if you're very, very, very familiar with hyperbolic geometry, and then you see a hyperbolic symmetry group, yeah, it could crystallize it, and it's going to be easier to see. The reports that I've heard, it's much more in the direction of, oh my gosh, there was all of these different diverse, strange things that once I understood that hyperbolic geometry was underneath all of them, they all clicked and made sense. So for a number of them, they didn't have the hyperbolic framework to begin with. And it kind of like with that framework, they were able to reinterpret a lot of what they experienced. That said, if you do have the framework, that very likely does modify your experience to some extent. And I would suspect actually for the better, because it allows you to navigate the state better, and specifically be able to experience those low information hyperbolic honeycombs that are very blissful. And if you don't know those exist or are possible, you may be missing out on them. Over here?
Yeah, so I guess there are a lot of different works of art that you could talk about which would sort of embody these different characteristics, but specifically like just thinking about greater art historical trends with the advent of like abstract expressionism in the mid-20th century in America, like Pollock, for example, who probably most people here are familiar with, right? He's not painting spaghetti, right? He's not painting like anything figurative, but sometimes like when I was young and I first encountered a Pollock, I like imposed that figuration on it. And when I hear people give narrative accounts of their DMT trips,
Yeah.
often I wonder to what extent are they sort of imposing this figuration on shapes which they can't process, which I guess makes my question sort of similar to yours, but I'm wondering, do you think that if you are less familiar with these sorts of shapes and what they are objectively, that you might have a more sort of metaphorical, because you'll be forced to sort of have these more analogical ways of thinking to actually process this, and maybe it will be more narrative and more poetic in a sense if you're not sort of using these conceptual molds to put your experience into a
Yeah, no, I agree completely, and yeah, I think that's the case. So we do emphasize, sorry.
Yeah, so like, and also the point of that is like, do you think there's a point where literally, even if you do have the ability to like internalize these mathematical truths, which like, you know, some of my friends who do physics and stuff, they can describe it elaborately in mathematical terms, there's a point where even, you know, the greatest mathematicians or the people who are most adept with whatever mental faculty that is, they can't actually process it. Like, even the greatest musicians can't listen to static, radio static, and hear Beethoven.
Is it possible for the brain to have pure experience?
Maybe that's a side question, for sure. Like, radio static, let's see, Beethoven is coming from FM radio, and it's distorted enough, you can't hear, yeah, exactly.
Yeah,
so,
Amnesia level.
I guess maybe that's the
but yeah, just one note. I mean, this is a little bit of terminology, but it's really important. The thing that I emphasize is the importance of talking about the phenomenal character of the experience as opposed to the intentional content. So this idea of, oh, I went to my DMT trip and I saw a dragon breathing liquid nitrogen. It's like, well, how do you know it was liquid nitrogen? How do you know it was a dragon? Like, it had like the feeling, but that doesn't actually tell you very much about the experience. It's much more informative if they say, oh, and the dragon had, 632 symmetries on its fur. It's actually bringing back something structural about the experience. Or here's another very helpful metaphor, which is that if somebody says like, oh, on LSD the sound of music is way better. Okay, that's somewhat useful. If somebody says, oh, whenever I hear a pulse on LSD, it sounds like the reverb impulse response of this particular reverb pattern I can find in Adobe Audition. Like, okay, that's very, very helpful.
Yes.
Right? So we're talking about kind of shifting how we study psychedelics towards the phenomenal character and away from the intentional content, to the narrative.
Okay, I see what you're saying.
Yeah. There's maybe more questions.
Yeah, go ahead.
Over in the back.
Yeah, so that's very cool, thanks. It seemed to me that you focused a lot on the visual component of, and I'm curious about like whether your research also extends into other sensory modalities. You touched on like emotion,
Yes.
you talked a little bit about like narrativization, but what about like things like texture and proprioception and audition?
Yeah, no, broadly speaking, this generalizes. So, simple example, it sounds ridiculous, but see, apparently it's true. If you take both of your hands and you run them through a carpet, and you can kind of like notice all the like details of the carpet, the way in which they're irregular. On a sufficient dose of LSD or DMT, you will experience the texture in both hands synchronized and feel like they're the same waves. So there's like this sense of like the threshold for entrainment and the threshold for patterns to copy each other gets lower, and that happens across all modalities. So it's not just visual. Visual is just like easier to talk about. but I mean, take for example symmetry, right? Like these Euclidean symmetries I was talking about. What is the analogy of symmetry in sound? Well, there's actually two very close analogies. One of them is simple rhythm and repetition. People talk a lot about like thought loops that happen on psychedelics. You can think of that as, and also sound loops that happen on psychedelics, hallucinatory sound loops. And also the other is reverb. Basically, when you apply reverb to something, you can interpret that as smoothing it. And in that sense, it's also applying symmetry to it. So, yeah, the short answer is it applies to all modalities.
Let's do like 2 more questions.
Let's do 3 more.
3 more? Yeah.
So, what is what you've learned with these hyperbolic spaces and stuff teach you or indicate to you or get you thinking about relevant to like current, normal, non-DMT experience? Like what layers behind what I'm experiencing right now might you have learned or been intimated towards?
Yeah, quite a bit. So I would say that you do have, in normal everyday life without any substances, you do have moments of high energy. They usually don't manifest in a particularly psychedelic sense, which is like broad spectrum activation. Tend to be much more narrow. But even within them, you will start to observe that there's like similar patterns. For example, there's a lot of people who describe kind of like a similarity between psychedelic bliss and orgasm. And there's like a sense in which orgasm, you can think of it also as a wallpaper symmetry, but in the body feeling. So I would say, yeah, we're kind of like pursuing symmetries, whether we realize it or not. It's only in kind of the extreme cases where they're happening all over the place that you know that that's kind of your algorithm. But I would say, yeah, that's happening in everyday life. Cool. Yep.
So I'm wondering about the computational implementation of this sort of phenomena.
Yes.
All of this seems a lot of like searching the space of programs. In your mind, you have these primitives that pretty much define how spaces and shapes in 3D world should look like. And when you get DMT, it seems to me that DMT gives a form of additional computational units, so like you can imagine hyperbolic spaces and all these fractal patterns and so on. And I was very interested when you mentioned annealing, because there is simulated annealing in artificial intelligence, which is this idea that like you just reduce the temperature of exploration versus exploitation, and you find these patterns. So I'm wondering like how do you think DMT implements these fractals in your mind?
Right. I'll try to give a short answer. Let's see. Try to give a 1-minute answer. So you kind of have to think about like various levels of organization. You have like, on the one hand, like what is the information that is getting processed, but then the other is like what algorithms are making that happen, and then third is like physically, how is like the physics of your brain implementing the algorithms. When it comes to the physics, I would say like a very likely candidate is connectome-specific harmonic waves, basically the natural resonant modes of your brain. Selin Atasoy developed this paradigm in 2016 and published it in Nature. And in 2017, she basically analyzed what connectome harmonics look like on LSD. And what she found was the amplitude of all the harmonics goes up, and especially the high frequency harmonics. In some sense, that's kind of like legitimizing the notion that on psychedelics you are literally energized. Like your consciousness literally has more energy, at least defining in the sense of like the amplitude of connectome harmonics. Now, that's not enough for annealing, right? For annealing, you still need something else. And the other thing that she found was that the repertoire of states increases. That is to say, the possible combinations of harmonics increases, meaning that you can do this sense of constraint satisfaction solving by relaxing the constraints and then annealing by heating it up and cooling it down. So there's a very physical reason why maybe this may be happening.
What was the name of the person?
Selin Atasoy.
Could you spell it?
Selenatasoy. Yes.
So I think this will be the last question, then you could talk afterward. But you're in a room with 50 to 60 intelligent people who are not only interested in psychedelics, but interested in hyperbolic geometry, DMT experiences. What would you ask them to think about going forward, or what could consciousness research benefit from in the future from people here that could advance the field?
Yes, okay, so a couple things. First of all, yes, do think about kind of like annealing framework, about symmetry, especially about valence. Like during a psychedelic state, think about like in what configurations of your consciousness do you feel better? And email me if you find interesting results. No, seriously though. I would actually ask you, is it the case that when you converge on these like, you know, high-dimensional hyperbolic resonant states, does that feel good? If somebody says, I hated it, please email me. I'm looking for counterexamples. As far as I know, that feels great. But yeah, looking a little bit further ahead, there's like two things I could ask. One, we have a how to volunteer page on the Qualia research. We have a number of really interesting projects. We just don't have enough resources and time to do. And we love self-starters. So if at some point, and I guess this is the last point, at some point you want to join us, definitely a really great way to do that and to basically bring yourself to our attention is to maybe find one of the volunteer projects or come up with one yourself and show us some work. And we may be able to bring you in, and that would be awesome. Okay. Yay!